Welcome to the Sculpted Table project. In this video, I'll be taking you through the steps necessary to create this great piece. The first subassembly we need to create is the center post. It has a rather unique shape, but it's really the backbone of the entire piece, as all other parts are attached to it. The center post starts with two glued up pieces of 6/4 wood. Each of these pieces start with boards that are roughly 20 inches long, 2.5 inches wide, and 1.5 inches thick. Mill two identical blocks of wood to these rough dimensions, making sure they're flat and square. But don't worry about being too exact at this point, because we'll be cutting them to final dimension later. After milling, we then glue these two boards together, clamping them securely from both sides and ensuring there are no gaps between the boards. Allow them to dry overnight. Don't worry too much if the boards aren't perfectly aligned, as we'll fix this in the next step. Once the glue is dry, remove the clamps and place the board on your jointer to where the seam between the boards is vertical. Joint the block until it's flat, which removes the excess squeeze out from the glue joint on one side. Take the block over to your table saw, set your fence at 2.5 inches, and rip the board, making sure that the seam is again vertical. Then move the fence to 2 inches and rip the opposite side of the board. This way the glue joint remains in the exact center. Rotate the piece 90 degrees and rip the board again. The finished block should now be perfectly 2 inches square and the glue joint in the center. Alternately, you could simply plane the board until it's 2 inches square, flipping it over with each pass. After that's finished, cross-cut a straight edge on one end and then measure 18 1/8 inches from that end. Cross-cut the board at that mark to final length. The next thing we need to do is dado all four sides of the center post. Put a 3/4 inch wide dado set in your table saw and raise the blade to 1/4 inch high. Set your fence to 5/8 of an inch and dado one side. Then repeat the dado on the remaining three sides. Next, we need to create a cove on all four corners of the block. Start by putting a 1/4 inch radius cove router bit into your router table or shaper. Raise the bit 1/4 inch high and ensure that the fence is flush with the bearing. This will create a perfect 1/4 inch radius cove. Slowly run the center post over the bit and repeat this for the remaining three corners. Okay, the center post is finished. Let's set it aside and move on to the leg subassembly. The leg assembly actually consists of three parts, glued up and connected using dowels for strength and alignment. The topmost part is referred to as the arm. The bottom is the foot, and the middle is the spine. We start with the spine, which is a piece of 6/4 wood measuring 18 inches long, 5 inches wide, and 1.5 inches thick. Mill your wood to these dimensions and rip or cross-cut accordingly. We then place a 3/4 inch dado head into our table saw, raising the blade 3/8 of an inch and set our fence to 4 3/4 of an inch. We need to create a rabbet along one side of the board. So run the board through the dado blade, flip it over, and repeat. The next step is to cut each end at a 45-degree angle using our miter fence. Replace the dado blade with a standard one, set the miter fence to 45 degrees, and mark 3/4 of an inch from the edge of the board. Make the cut, then flip the board over and repeat for the other side. The arm is built using a board that measures 8 inches long, 3 inches wide, and is also 1.5 inches thick. After milling and cutting your wood to these dimensions, cross-cut the arm at a 45-degree angle at the corner. Lastly, we need to create the foot. This board measures 8 inches long, 5 inches wide, and again 1.5 inches thick. Mill and cut your board to these dimensions and set it aside. There's no need to create a 45-degree angle on the board, as we need to keep the grain going in the right direction, that is, along the length of the foot. Lay out the 3 boards from the above steps and line them up, making sure the template fits over the assembly. To lay out the marks of the arm spine joint, measure 1 1/8 inches from the edge as shown here, and draw a line across the joint. Draw a second line 1 1/8 inches from the first, again across the joint. For the foot, draw a line across the joint that is 1 1/8 inches from the edge, and then draw another one that is 1 1/8 inches from the first. Transfer these marks across the end grain of all boards, and then make a pencil mark in the center of these lines. We can now drill for our dowels. We're going to be using dowels that are 3/8 inch in diameter and 1.5 inches long. If you have a horizontal boring machine, it can be used to drill for these dowels. However, as an alternative, you can use a doweling jig sold at many woodworking supply stores. Place a 3/8 inch drill bit into your drill, and using your doweling jig, drill a hole on the marks, boring to a depth of 3/4 of an inch. Do this for all boards. You should drill a total of 8 holes. Okay, it's time for some glue up. Spread some of your favorite wood glue on all the joints. Insert the dowels into each hole and then assemble. Clamp the arm to the spine, making certain that the joint is free of gaps. For securely clamping the foot to the spine, it's necessary to create a temporary clamping block. This block is nothing more than a piece of scrap wood cut into a triangular shape. To hold the block in place, a wood screw is temporarily screwed part way into the rabbeted edge, about an inch or so from the bottom as shown here. Loosely place the clamping block against the screw and hold it there while clamping the pieces together. This will help ensure that the joint is strong and free of gaps. This entire assembly needs to be repeated for the remaining 3 leg assemblies. After each assembly is completely dry, place your template against the board, making sure that alignment is flush against the rabbeted edge. Trace the outline of the template onto the assembly. Finally, bring the assembly over to your bandsaw and carefully cut it out. The next step is to round over some of the sharp edges. Place a 5/8 inch roundover bit into your router and route from the area just below the knee on the foot all the way to the top of the arm as shown by the white area here. Next, we can round over the underside of the foot. Start your round over just after the rabbit, and round over all the way to the end of the foot as shown in the white area here. Now we need to chamfer a 30-degree angle on the top part of the foot, as you can see in the white area here. Place a 30-degree chamfer bit into your router and extend the bit about 5/8 of an inch. Route the edge from the end of the foot all the way until you are about 1.5 inches from the roundover and stop there. Repeat these router passes for the other side of the leg assembly. After the routing is complete, there's a small area between each of the router passes that might look a little strange. You'll also notice that the two chamfered edges don't quite meet at a clean line. We're going to fix both of these issues now. Grab a good quality rasp and carefully transition from a rounded over edge into the chamfered edge. As well, you should improve the chamfer with the rasp until the two edges meet at a nice clean point along the foot, as shown here. Now, let's repeat this entire process for the remaining 3 legs. Nice work. Now let's move on to the tabletop. Let's start working on the tabletop. The tabletop is constructed from 3 boards, each one measuring 24 inches long, 8 inches wide, and 3/4 of an inch thick. Mill your wood to these dimensions, making sure that all joints have perfectly straight edges. After the glue is dry, trace a 22-inch diameter circle onto the wood using a compass or other circle-making jig. Take the board over to your bandsaw and carefully cut it out. You should cut it out slightly larger than the line you've drawn, as we'll clean it up in the next step. To clean up the edge, you'll need a circle router jig, either made by yourself or purchased from a woodworking supply store. You'll also need a straight spiral cutting bit, which is 1/2 inch in diameter. Insert the bit into your router and attach the router to the jig. Then place the jig onto your tabletop, making sure the edge of the router bit is exactly 11 inches from the center point. You should also ensure that the router bit is extended far enough to cut through the entire thickness of the wood. Carefully route around the edge of the tabletop. Next, you'll need a 3/8 inch roundover bit which also has a bearing. Place it into your router and route around the edge of the tabletop. Flip the top over and repeat the roundover on the other surface. We can finally start to assemble our sculpted table. First, apply some wood glue into the dados of the center post. Then apply glue onto each of the rabbited edges of the leg assemblies. Turn the leg assemblies upside down and insert them into the center post, making sure that the arms lay flat against your work surface. Clamp across each of the legs, the spine, and also the arms. Be careful when clamping across the legs, however, as excessive clamping pressure can weaken the dowel joints. Just clamp with enough pressure to ensure a good glue bond. Once the glue is dry, remove the clamps and rasp the underside of the legs where they transition into the center post. Your goal here is to remove all the sharp edges and blend the legs into the center post at each of the corners, as shown here. With the entire assembly still upside down, we can now drill for our tabletop. Mark the center of each of the arms about 1.5 inches from the outer edge. Drill a 1.5 inch hole with a Forstner bit about 1/2 inch deep. Next, drill a pilot hole all the way through each of the arms in the center of the first hole. Use a 3/16 inch drill bit, but this can vary depending on your choice of wood screw when attaching to the tabletop. We need to be aware of the wood movement which will occur in the tabletop and should orient the grain direction along the axis of 2 of the arms. This way, when the wood moves along its width, as shown here, we can allow for this movement. The 2 pilot holes along the length of the tabletop can stay as they are. However, the 2 holes securing the tabletop along its width should be made into slots. My method for enlarging the 2 pilot holes involves drilling at an angle from the top of the arm, using the same 3/16 inch drill bit as shown here. Before we actually attach the tabletop, now would be a good time to do some final sanding. Starting with 80 grit, sand the entire assembly, including the tabletop. Then move to 100 grit, 150, and finally 220 grit. After the sanding is complete, attach the tabletop using your favorite wood screws, making sure they are long enough to secure the top, but not too long to where they come through the top of the table. Into each of the 1/2 inch holes, insert a wooden plug to hide the screws. For the sculpted table, I typically use 1/2 inch plug cutter to cut plugs from the same wood as the table. This way they disappear after they are sanded smooth. We can finally apply some finish. I like to use the Maloo finishes, however you can of course use any type of finish you desire. My method for the Maloo finish involves 3 coats of the poly oil finish first. Each coat is applied and then wiped off, allowing 24 hours to dry between them. I then apply 3 coats of the oil wax finish using the same exact method. Whatever finish you decide to use, just be sure to follow the instructions on your choice of finish carefully and safely dispose of your rags or finishing supplies afterward. I really hope you've enjoyed building the sculpted table. Thanks for watching, and I look forward to seeing your finished projects.